I do. I don't know what.
That's the question yesterday.
Go anywhere after the trip?
True.
Yeah, you were leading a delegation down to the trip.
We went to the Key Centre. Much closer.
Yeah, much better that from the track across town.
It's all eye candy. All it is a little box in the middle.
Yeah.
All it is.
But it's just Mindstorms.
Yeah.
Never used Mindstorms.
How do you mean?
As in,
We've
got Mindstorms kits.
We've got these two kits, yeah, these two.
And then
We're going to have to
used for anything like
so we're going to be using them in February, developing them for that. We need to get a couple more, and these are the retail versions,
yeah,
which are a bit worse than the educational version. The educational version has got an additional sensor and has rechargeable battery packs. These are throwaway battery packs.
throwaway battery
Well,
pack.
six AA batteries.
Oh, yeah. So you could put in 6 rechargeables.
Yeah, well, yeah, except every recharge is full. So you,
Oh yeah, okay. So you need 2 recharges.
or yeah, we'll do them one after the other, which is really annoying. But I got some dirt cheap rechargeable batteries from Anchor Store, £3.50 for 4.
Yeah. You get me in cheap from them. You get them 2 for £1 in the pound shop.
Yeah?
But they are rubbish. They're only 800.
Oh,
So
these are
milliamp hour ones.
21.
Yeah. Yeah, it's worth paying the extra.
Yeah.
I ended up buying from Louise and Rest, but I ended up buying jewelry ones online for, I think I got 8 for about 14 quid, something like that, for jewelry sets. Rechargeables, which compared to the pound shop ones that we used to have, they just last. The pound shop ones you used to charge for daily, basically, there was a swap, actually probably a day and a half. So you put them in one night and then like lunchtime the next day, swap the sets and put the other ones on. Whereas the jewelry set ones would go for about 4 days. Swap them. And now they're all being repurposed into toys. Multitude of bleepy, battery-powered VTech type things that Eddie used to have, guitars.
Yeah?
Other naughty making devices. Guess what, just looking at these. They're only going to be 7 or 8 years.
Andy was saying that his 10-year-old struggles to get
Oh, really?
intense.
So yeah, well,
I mean, it is quite challenging, and you need good eyesight to interpret the construction diagrams as well.
Yeah.
They're all in one perspective, which means you can't necessarily tell where things are on figure orientation. education.
They need to have an augmented reality assembly guide, don't
Or
they?
just quick time to the horror, and so you can rotate it.
Yeah, or even you put the box on the floor and just move your thing around.
Yeah.
Let's put together different stages. There you go.
Well, I think I'm going to have to go to this one, otherwise it will be completely empty.
Go and have a look.
Hello, we're about to start the workshop on the Stewart exploratory stuff. If you'd like to move forward a bit, I think it's a really number of this. The front table will be Okay, right, I'd like to welcome you to the Construction Workshop. Murray and his colleague, Johnny from Warwick, have been working on new approaches to thinking about programming and other sorts of programming design things. So this is an exposition of how to do it. So it's going to be a bit different.
So thank you very much for coming along. I'm sorry that it's necessary to do this with laptops rather than tablets, but I think we can also do things on the screen as required. I should explain that if I'd known in advance about the nature of ITAG, a little bit more insight into what goes on here, I probably would have done something rather different yesterday. Because I think it's a little premature to tell you about making construals and what's involved in making construals without somehow motivating, explaining why we think that's very relevant to the work that goes on here. But perhaps one thing to say is that, as we saw a little earlier this morning, one of the remarkable things that completely transforms programming is the fact that we can create dependencies between one thing and another. Okay, the dependencies we saw today were Stephen waving his hands around here and seeing something on the screen responding, as if they were one and the same action. The movement of a hand was like the movement of something on the screen. And already you can see that the kind of things which Stephen is doing have made it very much simpler to program. It makes it possible to take the Scratch programming paradigm and make it exceptionally rich, expressive. What we're able to do in our work, what we're doing in our work, is pursuing the idea of what if we could make dependencies automatically throughout the entire software domain. So that's the first thing that you want to think about. What we are trying to show you is an environment in which dependency does not have to be programmed. it only has to be specified. You only have to say, I would like the colour of this object to be linked to the position of this object. And of course you have to learn to specify that. But it's a very different thing from writing a program in Scratch, because it's simply making a relationship, just expressing a static relationship. And the parallel for that, the precedent for that is in spreadsheets. So that's the first part of the news. The next thing I want to say is that our belief is that a very, very large proportion of the work that's done in software development right across the world is that. It's actually building dependencies between things. Because that's how we make our software link to the world and have sensible meaning. So, that's another line which Stephen said this morning. We have to tell the computer everything. It doesn't know everything. It's very difficult to know what it means to tell the computer everything. Because there are any number of ideas about how we give intelligence to a computer. Our thesis is that all our knowledge is rooted on understanding and experiencing relationships. And that those relationships are of the nature of dependencies between things. That's how we make sense of the world, is our thesis. So we're seeing this as a way of profoundly making the connection between meanings in a program and real-world meanings. And I think it's your mission, and I think more than any other community I've met, this is a community which seems to be very interested in using the computer to really get engaged with everyday life and make things accessible to people, get involved in the way in which their work. I think of Stephen's talk yesterday, for example, as how a blind person has a perception of the world. This is about making dependencies between a stick or other devices which are richer than the stick and the real physical environment. And what I'm suggesting is the tools we're offering can transform your ability to do that. That's the good news. The bad news is that if you want to do this, you have to, as I've discovered, completely rethink the way you think about software. It looks as if initially you think, well, all I have to do is to put this ability to express definitions and dependencies into existing software, and it will be straightforward. You've radically improved your software development skills. But this is not the case. Because if you take Scratch and you add in dependencies in just a casual way, it becomes an incoherent. It turns out you have to rethink the way you develop software entirely. And that's the bad news in the sense that that's the reason why what we show you looks initially, the things I showed you in the talk yesterday, they look very tame and small and simple compared with some of the things that you'd expect to see of a program. But the suggestion is that we can change the function. That's what we're trying to do. We're trying to give you a way of thinking about programming, which eventually, I believe, will transform the subject so that this division that Stephen referred to between the geeks and the people who do work that sometimes they even like to think of as inaccessible to the experts in other fields. These two things, I think, have to come together. We have to use our understanding of the real world and our expertise in the domains we want to talk about and bridge that to the technical world. So that's, I hope, positioning this in relation to your field. And that's quite enough talking. So for those of you who have got laptops, I think the first thing to do is to find the website. So perhaps we could switch at the back to our other screen. Yeah. So for the purposes of the workshop, we've set up. That's tricky. Getting there, two things really. I'm sorry, I didn't have the website URLs when we did this last week.
Basically, if I can just put that on.
That's what I want.
Can you,
Cloud.
is my screen,
Yeah.
and then,
So what we've done is to create a web page. The plan for the workshop is to have that little introduction I've given you now. But first of all, I want to get us doing something with an elementary construal that's related to what we were looking at yesterday, the shopping construal. And after that, I want to show you something a little bit more ambitious, but to give you a flavour of how this can be taken further. So it is
It's still here, but it's not there. Oh, no. First of all, let's see if we can share that. Well,
here we are. So those of you who have a laptop, if you could go to this address.
There's the Wi-Fi, free Wi-Fi here.
There is Wi-Fi via the cloud.
You have to go to the cloud. Yes, the person you have to go to the cloud.
that's slightly simpler. It's the same thing, but slightly easier to get in.
No, I think.
No, never mind.
I have a laptop here.
No, I had the same problem yesterday. So this is what.
We're hoping to get this webpage for you here on the
Yep, so, okay, so if everyone's got that, then hopefully you should get to that page, which is also
why is it not?
display seems to have been, I think my resolution is still too high for this monitor.
Has everybody got to the webpage?
Sorry, hold on.
If you have a laptop, then there are two links inside the page. The first page is the person to.
How about you were good enough to tell me the way you that makes sense? Yeah. Let's use that. Let's try that. Okay. So in that case, I'll go around individually while we're waiting for that. Has everyone got to that page?
Did you manage to do it? No, you have to give so many personal details before he gets you on. No, the same problem is that you do that.
You want to run the page?
We're on the right URL, but it's giving you the not that.
Yeah, I've got the screen part.
And we spent construct. There's
They're still funny things. The recruitment agency is easy as well. If you have a recruitment agency who start to report, you want to see easier to check. Because the one it's a similar communication.
I think everyone's job is to make
So, have you managed to get something together? Feel free if you want to be part of this one.
This one was?
It should be fine. It is okay.
What's the internet? What is the URL?
You don't need it because this is what you're going to get.
Oh,
Okay,
great.
I've set this up for you.
Thank you.
But we can't easily talk about this without time.
Yeah, that's not really.
That's all right. This is the only, when you're doing technology, the only risk is the chips go on. Can I suggest that if we actually grab around two tables and Murray and John take one table each, then we can at least do it live on the laptop while sorting that out.
If you like, although I think it should be there.
Guys, my screen works up there. Do you want me to?
Oh, yeah. No, okay.
Is that okay? That's downstairs.
Oh, I think.
Edge browser, best browser, fastest browser. Ah, there we go. What? Are you saying the Edge browser is not compliant? I think you'll find it. Yes, but Edge is not IE. They're not even right. But you wouldn't know that because you're one of those Linux. Anyway, here we go. So, there you go. Come on up. So that's the short link for your website, if you're wondering. And that's your...
Okay.
You can do whatever you use Firefox.
So how many of you have got to this particular place? Okay. So you get to this page by going to the URL we gave a moment ago and pressing on person scroll.
What was the URL?
Sorry?
What was the URL?
It was the one that was shown there before. Okay. You don't need the URL.
The first tab is very top, there's a bit.ly link.
Yeah, do you want to show them that, John?
Yeah.
Yeah.
So this is giving a URL, is it?
Just a bit.
Just a short one.
Which was the main page for
It's a touch screen, so you can pitch and zoom.
this one, okay. So,
Okay, Johnny?
I'm not sure, but okay.
So,
Can we, yeah?
this looks like quite a mess, I realise that, but it consists of two components. Over here, there's a worksheet, which you should expose at first. I think if you go to the options thing at the top, if you've got the same problem we've got here with lots of windows exposed, go to the options menu at the top and come down to hide windows on minimize. Make sure that that box is ticked. Okay? And then if you then minimize these windows, then they will disappear out of your site. So minimize all the windows. I think not the script input window, maybe, or if you don't want to, that's okay. Okay. Take that one away as well. Okay? And then I think we will want an input window. So on your existing windows, bring back an input window, a script input window.
Okay.
What we have here is a worksheet. And if this worksheet isn't in a very good format, as this is, we can expand its size on the screen. The thing to remember, the mental model of what's going on here is not like a traditional program. It is a script of observables. So observables to do with everything that has to do with the state of the things you see on the screen. So every single element of the screen, like what's on this picture, what this text is here, the format of this text, what the size of that worksheet, all those things are controlled by observables, which are in some great big stack of observables. And anybody, in principle, can interact with them through the script input window. So for example, there is a variable in there which will determine how big this is. So if this isn't laid out very nicely for you at the moment, then we can put in here something like page, lowercase page, capital W width, and we can put it equal to, I think it's a percentage of the whole, so let's make it more like 60%. And then we have a feature here called live coding. If we press this button,
Without the percent.
without the percent,
Sorry.
we don't need a percent.
Yeah.
So page width equals 60, you can see that. If you press here, then this turns this into a live coding environment. It should mean, I hope. Oh, have I got the right number? The right thing?
Maybe it was already. No, can't
No,
be.
it's probably.
Yeah, it sort of already was. There we go.
Okay, so that's on page 80. Okay, page width 80 will make that bigger. And in the process, it's updating this. So what we're doing here, remember, you've got the mental model of what I've got here is a stack of observables, a very large one with perhaps hundreds of observables in it, maybe thousands. And this script input window is like looking in, and it's changing one of those observables. But when we change the page width, all the things that depend on page width are being transformed at the same time. Okay? And that's all you need to know about changing state in this model. Whatever changes state, whatever kind of thing you want to do, it's always to do with redefinition of something. So let's work our way through the thing. I mean, if we can minimize this. Is everybody roughly up to speed now?
Yeah.
Okay, we'll move the canvas here.
No, is that right?
You
I'll
will
just
have-
move that down.
This is just a prototype development in the last release, this version of things. That's why it's rather rote. So, first bit of discussion is saying something like what I said at the outset of my talk yesterday. We're thinking about a situation where we're trying to make sense of somebody using a purse. And we're trying to make an interactive artifact that will reflect that understanding. So, think about a child watching somebody taking money out of a purse. What they actually see, if you go down here, we've got an embedded copy of the canvas inside here, and Johnny will be able to take things out of the purse by clicking on them. Also, that's putting something
putting
back in
it
the
back
purse.
in. So let's have a pound out.
Okay, and you've no idea what Johnny's trying to buy. You're the child, you're just watching him do this. So it's all rather mystifying. In fact, I think you'd find that Johnny hasn't got enough money to buy whatever he wants at the moment, so he probably wouldn't even start. He'd regard it as a pointless exercise. But the point is that when we think about the things that matter in this situation, this artifact has to be richer than this because it's got to reflect what Johnny's thinking about, namely the cost of something he wants to buy, whether he's got enough money, how much change he would get, how he would choose the coins to buy it. So there will be a lot of other things in there, and they are actually in this model. Now, one way we can get some insight into what's in that script of observables that defines the current state is to actually inspect some of them. So down here, if you've got this on your screen, you'll find a show observables command. If we make that live, then that brings up, this is a piece of the script, which is all the observables whose names match to this particular expression. So just think I've selected from my script a set of observables which match to some particular syntactic form. But by the way, a little bit of feedback, am I on about the right level here now? Are you more or less understanding, or is this totally, is reasonably okay so far? Okay, so here we've just viewed a piece of the script. And this will tell you various things. You might be able to read it from the back, but possibly you'll see that, for example, the total cost of the items that Johnny's trying to buy is 500, which is pence here, £5. You can see that he hasn't actually got enough money, because the money he's got in his purse is all that up there, and you can see that's not £5. But if Johnny clicks the new purse button, okay, then eventually the average amount of money is off less than £5. Eventually you might have enough. Keep going. No, you have to go several times more, I think.
So 289, 234,
367. Any advance on that? 577. So finally, Johnny has got enough money to buy something. And from here, yes, so you can see how much you're offered. This will record, inside here we have other observables, which will say things like how much is offered. Perhaps we got change in here. Yes, change should be somewhere on this display. If you move this down, I think. Just change must be here somewhere. We get 20 times change. And now if we dynamically, so let's go to something like, suppose we try to buy something a little bit cheaper. So you can click on total cost here. Yeah. Just click on total cost. Just touch go. Oh, no, this part of it. Oh, sorry, that again. Then you get total cost is 500. The current thing we're trying to buy costs us 500. But if we put this into live coding mode, well, first of all, yes, you can change it like that if you like.
Well, at the moment it's 500.
Yes. If we then go and change this to something like, well, 100. Yeah, 100 or something, then you can see this will dynamically affect how much change. We've got £4.20 change here now. So this is what I'm talking about when I'm saying the script of observables has to reflect our real-world understanding of the domain. But this is what we go to tremendous efforts to do whenever we write any program to do with concurrency. There's bound to be this kind of dependency going on in it. And the problem is that most people have to write that, especially when they write that program. Whereas we're saying, we give you the mechanisms to do that. In this sense, but if you hover over this word change here, then you see, this is really the guts of our programming environment, if you call it a programming environment. We think of it as an environment that's richer than for making programs, it's for making sense of things. And in here it says change is offered minus total cost. And that means that if total cost changes, if offered changes, then change will change. Automatically, by dependency, as it would in the spreadsheet. And we don't have to program that. We just have to say we want it to happen. And it will happen. Okay, so that's why this system transforms programming. Not only in the sense that Stephen is talking about. I mean, obviously we aren't doing anything as clever as Stephen does at the interface level. But internally, transforming a lot of the rest of the mechanisms so that they also work by dependency. So let's keep on going. Is this questions or?
Yeah. We've quite got the same box as the show observable.
Yes. Yes, you will find that.
I've got something else as bus fare.
Oh, you've gone down too far in the script. Yes. Some of this, I'm afraid, because we've lost a little time, you need to reflect on time. But if we go down, yeah, let's put some of these away again for a minute. Now, yes, we can get rid of that. In this worksheet, which is really for something for you to read a little bit offline, the next thing I talk about is the way in which, back a little, I think, the way in which the things that we think are important in the domain when we are looking at the purse, the things like the spending money, the offer, the total cost, we have to give them names. We have to record them inside our script somewhere. So this is the next thing we're talking about here, how there will be names for things. And this is where, again, the very stark contrast with traditional programming is obvious, because these names are very critical. If I call these X, Y, Z, T, yes, you could play around with the environment and say, I think I know what X is because it behaves in this way. But the only way in which you're going to understand the meaning of my hundreds of observables is because they have names that resonate with things that matter. Okay, so you give them such names. And if you want to look at the values of those, then we can use this view mechanism more explicitly. If you go to the new window option, the top corner here, take observable list. You can choose for yourself what you put in the observable list. So copy this expression, Johnny. The expression here, spending money. That one. Spending money. Okay, sorry, you can collect the answer. It's difficult, is this? It's probably easy to type it in. So you click that and look for the search box. Yeah. You need to get rid of the quotes at the end, I think. Yeah. And is it so right at the beginning?
The first X. Oh, no.
Good. Okay, when you've done that, you get a lot of stuff here, which includes the key observables that you're interested in. And these views are views in which you're making sense of specific activities. Like, for example, whether I've actually got enough money, whether I've offered enough. So in this case, I'm saying whether there's enough money in my purse. And when you change anything here now, when you start interacting in the model, you can see this correlation. All these observables change in sync with taking things out of the purse and offering them, putting them back in the purse, changing the total cost, which is something we did before. All that stuff is dynamically kept in sync. So what I've latterly come to understand is a good way of explaining what we're doing in this work. It's to do with making connections in our experience of all kinds. So here's a connection between this picture, which sort of resembles coins, and this sort of more academic way of understanding it, more formal way of understanding it in terms of values of observables. There's a correlation between those, which you understand by putting them side by side on the screen and interacting with them. So that kind of making connections is what takes the place of traditional computing's emphasis on the formal understanding of things, the logical meaning. The meanings of things are all to do with, is there a connection between them? Can I make that connection? And of course, being able to make that connection depends on who you are. If you're a child, there's no way you're going to make those connections. You won't understand the concept of spending money. You won't read this and say, I put down £2.50. So it won't mean anything. Okay? But learning enables us to become acquainted with these things. Right, now how are we doing for time? What's the time now, Pam?
So we've got
So I hope, if you can take this away and read this carefully, you can get some idea of hopefully how these concepts play together. I think the other thing I did here, if we go down one page, just to draw attention to what you talked about, Karen, further down here, I said something like bus fare. But what I'm trying to stress is, when we write programs to do things like handle money, we try to think of all the possible contexts and uses we might have for them. When you build a construal, you make sense of a situation in such a way that if the situation changes or something opportunistically happens, you can transform your construal, which is much more like what we do in real life. I mean, I never really believe when I read the British Rail timetable to say I'm coming to Nottingham, but I'm actually going to leave Leicester at 8:30. I know very well that the train will not get there until 8:35, so I may have to get the next train, and so on. And then when I get there, I find the train doesn't leave till 8:40 anyway, because it's been delayed, so I get it. You understand what I mean? Everything, observables in life are like this. They're not like logical observables. And so, in the same spirit, I might actually have to keep some bus fare back. So whether I've got to have enough money or not is really not a matter of whether the money I've got with me is enough to buy what I wanted. I need to know whether I've got the bus fare as well. So then I can change this formula. We should have made this a bit bigger. Should we do that? Have enough money is bus fare plus total cost. I add the bus fare to the total cost. And now I have to think when I spend, well, I can buy my item and still have my bus fare. So this is this adaptability to the context. Change the state by changing our observables.
It's
Let's move
there's a lot of technical things he's talking about that you can't really see. No?
Time, I'm sorry. Let's go to the next. Go back to the other link on the web page.
No.
Yeah, go back to this web page. So if I can say the sort of 4 key messages out of what you've just heard are that building with dependencies is tremendously important about making connections in our activities. Observables, dependency, and agency are a way of thinking about how we model our environment, which is an alternative to programming. And the most important thing to hold on to is the idea that our understanding is about connections in experience that we can make, which might have to be learned, might depend on special abilities we have. I think the other thing that struck me yesterday is that what we're doing in making construals is very related to the agenda of creativity. The idea that you want fluid things, flexible things. These are words I was taking from somebody's talk yesterday, original things. This is what this is about. It's about making things that are flexible to go in different ways. So I'm illustrating that with respect to one of several construals we've made. We've only managed to adapt one of them to work with this latest version of our interpreter. So I'm sorry that they're not all available to you, but there are 3 links on the website. There are 3 construals mentioned on the website. This is the only one that's linked so far. We can move this way, Johnny, so it gets off the worksheet.
It's not responding.
Is it not?
That's not what we're going about.
Got it, Johnny?
Not responding.
That's very strange.
Alright.
Is it responding now?
Very slow. It's not responding.
So let me just tell you, you will be able to look at this link as well offline. Yes, so Karen has it.
I think it's because the bit at the back was highlighted.
Try again, let's see. Is that better now?
Keep looking at that tab. It says not responding.
This is not an experience we normally have.
I think this is, to be honest, we normally test this on Firefox and Chrome. This is Microsoft Edge, which I'll happily say that that was Microsoft.
So we will have it. We've never tested it or developed it for that platform, but it should work on Chrome or Chrome or Firefox. What I want to explain about this is that this is a larger scale construal, which gives you some idea of why we think making construals is an interesting activity that's different from traditional activities. If you write a program, you tend to have a specific functional purpose, like a fixed functional framework in mind. But in fact, you have to have one before you can talk about programming, in some sense. I know you can do agile development, but even when you do agile development, what you're doing is changing that functional specification, in some sense, or letting it be implied. You're not formally specifying it. In this environment, you haven't got a functional specification. That's very difficult to imagine. But that is the case, that you can use this in any number of ways, because it's I said it was a state, a whole bunch of observables. It's entirely in the way that you explore that state and the way that you instrument it with things that do automatic redefinition for you to take you around that space. That's what gives it its meaning. So its meanings are only in the interaction, which is very fluid and open. So at the moment we're using the construal in one particular way to do some very conventional activity, which is to colour this set of hexagons as a map. Things are being very slow, as Johnny said. Probably something to do with this setting up of current observers.
So this is having to sort of look at all the neighbours of what the colours are and sort of understand what's next.
So here it's giving me a little interface of saying I can colour this green, yellow or blue, but I can't colour it red because this is already red.
So effectively this one knows that each of its neighbours knows what its neighbours are. So they're linked by dependency in the same way that the shopping control had dependency.
Okay, so this has got dependency of that kind. But if we move this to the right, if you can possibly do that, it'll allow to move it. I think that it needs to do with that feature that it was slow. Any chance of thinking any film? Oh, what a shame. Right, let's see. I'm hoping to move down this worksheet. That's so fun.
Here we go, somewhere around there. Oh, sorry.
Okay. So the main thing to say is that because this is something whose functionality is completely open to you to devise interactively in situation, you can do all sorts of things with this construal. So we were looking at studying colouring, as it says. Let's have a crack at something a bit lower down. Let's try page 4. So down here I've listed completely different activities that you can do with this construal, which have different educational purposes. One of them gives you a lot of insight into what's really involved in manipulating these work observables below the bonnet, which is the nearest thing to traditional programming you have to do in this context. I want to go to page 4. So now we're on page 4. Let's press, we've got this wonderful problem. Let's press, if you get to page 4, which you can do by putting cur capital page equals 4, as changing one of the observables, it will select a different page by dependency, and so change the state. It now is addressing a different issue. How the hexagon, first hexagon that we drew here, which I think Johnny actually drew, not me, how it was drawn. So the picture is a hexagon, press live, here's the hexagon, the first one we drew. I'm hoping the canvas page will respond now, will it? There's something about the canvas drawing, isn't it? Yeah. That's a pity. Okay, well, you've got a hexagon. Keep going, if you can. Down the. No, I meant down.
Yeah, I know. I'm just trying to get both the
you need to go down the worksheet, I think, so if you can. Are you able to put this back?
Not this one.
Okay, good. Come back.
Let's just move that back there.
Yes, whatever you're doing. Right. Keep going down there. Let's try and do one or two of these things anyway. Yes, that's maybe a useful thing. Closer. I don't know what that's going to do. It might take a little age to do. I've made this into a big hexagon. So I've focused on looking at that particular one. Then by this action, I'll show you some of the construction lines that go into making this. Okay, so here's some construction lines. If you want to teach a little bit of trigonometry, keep on coming on further. And go down the script a bit further, down the worksheet. Okay, because the canvas pictures. Oh, right. Okay. Keep going down. And go backwards here. Oh yes, the basic trigonometry is under the next one here. Okay, if you click on this one, make this one live. Drive on. And then you can bring the canvas picture back. Okay, then you can see some elementary trigonometry. Now, my point is that this is just a way of playing around with that large set of observables, a way of exercising it, looking at it, making a journey, if you like, through this space of possibilities. So this could be a way of attracting attention to some small corner of that modelling exercise. And we could use this to do some basic trigonometry that might be an issue that somebody asked you about when you're building things. The nice thing about this environment is that everything you did before is still there. Those observables are still there. We just have to single out a few and show you a few. So it's all about the views agents can have on it. If we just go to the next page, if we can really do this, Johnny, I don't know. Okay. With this high-tech interface we got, getting a new page. Yes, maybe current page. Plus even. Okay, we add 1 to the current page. It'll not respond, will it? It goes, great. So on the next page, we can say, I don't any longer want to be in this very specialized context in which I'm only looking at these observables. I want to go back and look at the entire script as I had it originally. So here, that just means restoring the picture to what it was before and the size of things. So with luck, this might take an age, I don't know. It's gone back to where it was. Okay? So if you think about traditional programming, you will know that this is one of the classic problems of programming. That when you write a program, you execute a program, you get to some point and you think, that's wrong, it should have gone that way, or I really would like to go back to where I was before. That kind of undo here is very much, it's a very natural aspect of what's here. Because we're living the states we're going through when we're doing this kind of work. And so to revisit the state is just to recall the state of the observables as we have done it so long. Because all the interesting stuff, if you like, all the stuff that programmers consider interesting, is in the visiting, in the traveling. And that traveling is the bit that you can opportunistically do. Okay, now I would love to tell you more. I think you can look at this offline. I think I'm probably overstepping time. I'd quite like to get a bit of feedback and questions. I hope this has been a little bit intelligible, although it's been rushed. What do you think, Karen? How do you enjoy it?
Have you tried to teach programming or to teach concepts?
To some extent, yes. For example, one of the things we have, not in this environment, is something like heap sorting. When you teach heap sorting, you're getting students to think about data structures and drawing their attention. They have to observe certain things. So we have models like that, which spell out how something like heap sorting works.
What kind of feedback do you get from the students in terms of what they like and what kind of feature development would you do to?
Well, I did it very surreptitiously, Georgina, because as you know, I'm from a computer science department which does not encourage informal computing. It encourages formal teaching of logic and mathematics, and those were my responsibilities. So I was teaching data structures and teaching logic and databases, and I was surreptitiously saying, and I'm not alone in saying, relational databases do not seem to deliver to all the agenda. So we need something else. And I would infiltrate things to do with this. For example, we had a module in which I had an interpreter based on this, which did SQL, which, if you know, is not very good mathematically. It's actually weak, formally weak. It's got, doesn't do logical things very well. We made an environment in which you could switch between an interpreter which did SQL and more pure relational algebra. And that kind of showed the weaknesses. So I was doing it in a way where I didn't say to the students, you know, I just slightly backhanded.
I mean, it does make sense to use for SQL and trigonometry and
yes. But I think you could say that I think the best stories I have about our work. We have project students who did work with this over the years. Perhaps 10 years ago, I had a project student who had dropped out of the degree through being so disillusioned with the way we have to program, having been shown very formal ways of doing it. So he came back a year on, he did a project with us, never having seen this work before, and I think he did it greatly for his psychological well-being. He enjoyed this, he incrementally made a remarkable project over a period of time, and it wasn't, he never had to sit down and say, what am I formally doing? you could say, oh, I can do this, wow, that's interesting, that should be...
I was just wondering, Mary, but it might be useful could it be used with students who perhaps are not on main programming courses, so they're doing an IT-related course, but struggle with programming. Could you use this to sort of explain how the programs sort of work a bit? And, because I think sometimes we find, don't we, with IT students, they don't always get programming. In terms of what's going on, I'm wondering whether it might be useful.
It is. Let me just show you one more page, if I may. Is it the next page? Is this one? Yes, try this one. Well, whilst we talk, because this is relevant to your question. The two things to say about that. First of all, we hadn't realised when we started Construed that this is the product of many years' work from computer science students at Warwick. It's been taught to fourth-year students at Warwick, who see it as a very, very big contrast to what they've seen to that date. What we hadn't realised was, although we thought it was simpler than formal approaches, we were assuming a lot of things from computing. So I think, to answer your question, we certainly need to remove some of those implicit assumptions. We use language like function, definition, and action, and to give sense to them, we're thinking in computing terms. We need to sort of make it less special than it is. That sort of thing.
I think there's a possibility for it, showing how programs work, and so get a sense of what things are doing, but not overly.
That's exactly right.
Things they don't need later on.
Yes.
It's how you get that balance right, I think.
Well, another development, you see, in the Computing at School initiative, which is curious, it's come along at a very timely point for us, but on the other hand, we're just not in line with it, because we're really saying, don't teach these formal approaches, there's something else complementary that's broader. I mean, teach these as well. But what is interesting is when they come to teach this to primary school children, they cannot teach logic and algorithms in a formal way. They are resorting to much more metaphorical approaches.
And for example, conceptual development.
Exactly.
And algorithm
Exactly. And
what is scratch programming?
That's right. Sorry, I'll come to the question. What is interesting is they then simplify. And in simplifying, it looks as if we can be relevant to that. It looks as if we can make contacts with that, say, barefoot project or something.
So,
oh, yes. So that would be studying what people are doing with these models, perhaps, and monitoring and...
Yes, exactly. So the project that I'm working on is we set graded goal setting with a daily target, and obviously whether the person meets that daily target or what percentage of that daily target they meet. So there's quite a lot of application here that comes through in terms of trying to track and give that online feedback.
Yes. As a matter of fact, the Construed project has got 3 years, and we've got, for this year, one of our missions is to think about instrumentation for that purpose. But absolutely.
I'm just conscious of that. I think everybody next door is probably waiting for their lunch.
Absolutely, yes.
So can I thank Marie and John for facing a difficult situation this morning and still trying to do positive things with us. We've got a sense of how things work, and obviously we can have further discussions. Let's say thank you to Marie and John for their battling on and for the challenges they're putting in front of us. Thank you.
Thank you very much for putting up with this. But seriously, if you're interested in working